Hello everyone, and welcome back to the channel. Part 1. Today, we're taking you behind the scenes to witness the detailed and methodical process of manufacturing alloy shafts used in industrial flour milling machines. These shafts play a critical role in ensuring stable, long-term operation under heavy mechanical loads. Let's walk through each stage together. The process begins with material selection. Large cylindrical billets of alloy steel are prepared. These are the raw foundation of the shaft. Workers carefully inspect the billet surface and move them into position using heavy-duty lifting equipment. Every movement is precise, ensuring safety and efficiency. Next is the turning phase. The billet is placed onto a massive industrial lathe. With steady hands and trained eyes, the machinist trims down the surface, reducing it to the desired diameter. Sparks fly as the cutting tools shape the metal with millimeter-level accuracy. The shaft slowly transforms into a uniform cylindrical form. We then move to the key grooving operation. A slot is carefully carved along the shaft's surface, ensuring perfect alignment. This slot allows the shaft to lock into rotating systems later in assembly. The machinist frequently pauses to measure and confirm exact dimensions using calipers and gauges. After that, heat treatment is applied. The shaft is heated to a high temperature inside a furnace, then cooled under controlled conditions. This strengthens the metal's internal structure, boosting its hardness and wear resistance. Once hardened, the shaft goes through a grinding process. This step ensures the final surface is smooth and precise, removing any micro imperfections caused by earlier machining or heat treatment. You'll notice the technicians double-checking the tolerances multiple times. It's a testament to the quality control in place. Finally, each shaft is cleaned, coated in anti-rust oil, and packed for delivery. These components will soon be installed into heavy-duty flour mills, ready to handle thousands of hours of continuous operation. And there you have it. Each step, from raw steel to finished alloy shaft, done with precision and care. Part 2. We're taking a close look at a fascinating industrial process, turning scrap metal into precision gear components for ammonia compressor systems at a local factory. Let's dive into the skilled craftsmanship behind every step. We begin with raw scrap material, mostly steel, being selected and sorted by hand. Each piece is carefully inspected. Only dense, solid fragments are chosen to ensure structural integrity. This seemingly simple task requires experience, as the wrong mix of metals can ruin the entire casting process. Next, we move to the melting stage. The workers load the selected scrap into a heavy-duty induction furnace. Once powered up, the furnace begins heating the metal to an extremely high temperature. You can see the glowing orange as the metal liquefies, a stunning sight that reflects the raw power of industrial technology. When the molten metal reaches the required consistency, the team prepares for the mold casting. They align pre-shaped sand molds with precision. These molds have been engineered specifically to replicate the fine details of compressor gear teeth. Timing and coordination are crucial at this stage. Any delay or misalignment could cause a flawed casting. The molten steel is then poured into the molds steadily, without splash or interruption. The pouring is done smoothly, with controlled flow, showing the level of expertise required. After pouring, the molds are set aside to cool naturally. The workers monitor temperature and wait patiently. No shortcuts are taken. Once the metal has solidified, the molds are broken apart to reveal rough gear shapes. These castings are then taken to the machining station. Here, the gears are refined using powerful lathes and grinders. Every rotation is measured. Workers focus on perfect tooth alignment and smooth surfaces, essential for the high-pressure demands of an ammonia compressor. Finally, a thorough quality check is performed. Dimensions are measured with calipers and micrometers, and surface finishes are inspected by touch and sight. Only the most precise components make it through. This is not just recycling, it's transformation, where scrap becomes precision machinery. A beautiful combination of strength, skill, and science. Part 3, we're taking a deep dive into a fascinating process, how digital weighing scales are manufactured in developing countries. While often overlooked, these small machines are vital tools in markets, farms, factories, and clinics. Let's closely examine each stage of the production process, from raw materials to final testing. First, we see workers handling metal sheets that will serve as the base structure of the scale. Using basic cutting tools and compact hydraulic presses, they carefully cut each component to size. The precision in this step is crucial, as it determines the balance and structure of the entire product. Next, the metal pieces are bent and shaped manually, or using simple forming machines. You can tell how experienced the workers are. Every movement is efficient and deliberate. Holes for screws and sensors are drilled using mechanical drills without computer-guided automation, yet the alignment is impressively accurate. Then comes the core, the load cell sensor. This is the part that converts weight into an electrical signal. A worker carefully attaches the sensor to the frame using screws and adhesive. Wires are connected by hand, one by one, with soldering irons. No fancy robotics, just steady hands and years of experience. After assembling the inner components, workers begin wiring the control board and digital display. Most parts are sourced cheaply but cleverly integrated. Each wire is tested and connected manually. You'll notice how they use multimeters and small tools to ensure everything functions correctly. Once assembled, the scale is carefully housed in a plastic or metal casing. In this facility, the casings are molded off-site and brought in. The workers mount the casings, screw them shut, and begin testing. Final step, calibration. Each scale is loaded with known weights and adjusted using internal settings until the readings are accurate. It's a slow and precise task, but vital for a trustworthy product. Despite limited resources and minimal automation, these workers produce functional, reliable devices using a mix of ingenuity and craftsmanship. Let's appreciate the hard work and dedication that goes into building even the simplest machines. Part 4, we're diving deep into the fascinating world of industrial craftsmanship. In this video, we'll explore how skilled workers in a local factory meticulously manufacture truck wheel axles, a critical component that must endure extreme loads and constant motion. Let's take a closer look at each stage of this precise process. At the beginning, we see the raw steel bar being loaded onto a rotating platform. This isn't just any steel. It's a high-grade alloy chosen for its strength and durability. The operator positions the bar with exact alignment to avoid imbalance during rotation. Precision at this stage is essential. Next, the lathe machine comes into play. The worker adjusts the controls and lowers the cutting tool gradually onto the spinning bar. As the sparks fly, the machine begins to carve the surface into a smooth, cylindrical shape. The steady hands of the operator, combined with a keen eye, ensure the axle reaches the correct diameter. After rough machining, it's time for the detailed work. The shaft is repositioned for fine cutting. The worker now switches to a finer blade and adjusts the tool path carefully. This phase involves careful measurement using micrometers and calipers. Even the slightest deviation could lead to imbalance or failure under stress. Once the shape is perfected, the axle is transferred to the next workstation. Here, chamfering is applied to the edges, a small but crucial detail that prevents sharp corners and stress concentration. The worker carefully grinds the ends, giving them a clean bevel. The next step involves creating the central groove or bearing seat. This is done using a specialized cutting tool mounted on a CNC lathe. The worker monitors the digital display and fine-tunes the depth of the groove with high precision. It must align perfectly with the wheel hub for proper functioning. We then move on to the polishing phase. Using a high-speed buffer, the surface is smoothed and shined. Not only does this improve aesthetics, but it also reduces friction and wear during use. Lastly, the finished axle undergoes inspection. The worker uses a dial indicator and laser measurement tools to check straightness and roundness. Only components that pass every metric are approved for final assembly. What's truly impressive here is the level of focus and care at each step. Every move is purposeful. Every adjustment is intentional. This isn't just factory work. It's skilled craftsmanship built on experience, precision, and pride. Part 5, we're stepping into the heart of heavy-duty manufacturing to witness how a truck suspension system is meticulously crafted, step by step. Let's explore the precision, strength, and engineering that go into every component. First, the process begins with steel cutting and shaping. A long steel plate is fed into a heavy-duty cutting machine. With absolute precision, the worker adjusts the alignment, ensuring each piece is uniform. Sparks fly as high-powered blades slice the metal into perfect segments. These will form the foundation of the leaf springs. Next comes heat treatment. The cut pieces are transferred into a massive furnace. At extremely high temperatures, the steel becomes malleable, enhancing its durability and flexibility. After heating, each piece is carefully removed and immediately dipped into a quenching tank, where the rapid cooling strengthens the structure. Now we move to forming the spring curves. The worker places each steel piece onto a hydraulic press. With controlled force, the machine bends the metal into its signature arc. Every curve is measured with a calibrated template, ensuring consistency. This step is critical to achieving the right tension and rebound in the final suspension system. Once shaped, the springs are drilled and assembled. Multiple leaves are stacked in descending sizes, forming a spring pack. A technician drills through the center, creating a bolt hole that will hold the leaves tightly together. He inserts a center pin and tightens it precisely to ensure structural integrity. Now, the technician proceeds to attach bushings to the ends. These rubber components reduce vibrations and friction when mounted to the chassis. The bushings are pressed into place with specialized tools, one by one. Finally, the entire leaf spring assembly is cleaned, coated in anti-rust paint, and quality inspected. Each unit is measured, stress tested, and verified to withstand the weight and motion of large trucks. And there you have it, a full journey from raw steel to a rugged, load-bearing suspension system. Every step, every motion, and every detail is a testament to skilled labor and mechanical precision. Part 6, we're diving deep into the fascinating and precise world of heavy-duty shaft forging. In this video, we'll explore the meticulous process carried out by skilled workers at a local forging plant. Let's watch closely and review each step like an expert. We begin with the preparation phase. One of the workers selects a massive steel billet, which is then transported using an overhead crane. The raw material is placed inside a high-temperature furnace, where it's heated until it glows bright orange. This heating process is essential to make the metal malleable and ready for forging. Once the desired temperature is reached, the red-hot billet is quickly moved onto the anvil area using heavy-duty tongs. This is where the true craftsmanship begins. A massive hydraulic press or power hammer comes down with tremendous force, repeatedly striking the billet. Each blow is calculated to gradually shape the metal into a rough cylindrical form, the early stage of the shaft. Next, a skilled operator carefully rotates and repositions the shaft between hammer strikes. This ensures the metal maintains a uniform shape along its entire length. Sparks and scale fly off as each hit compresses the internal structure, removing air pockets and improving the shaft's strength and integrity. After forging, the piece is transferred to a trimming station. Here, excess material is cut off using a shear press. This step is crucial for achieving the correct dimensions. The operator then inspects the forged shaft, measuring it precisely to confirm it meets the required specifications. In the final phase, the shaft is allowed to cool in a controlled environment. This slow cooling helps relieve internal stress and prepares the shaft for further machining or heat treatment. Each step in this process demands both experience and precision. From controlling the temperature to shaping and finishing, the entire workflow showcases the expertise of the workers and the power of industrial forging. Thanks for watching. Stay tuned for more behind-the-scenes insights into how the world's toughest components are made.